In this video, we are looking at how to use sequences of numbers, how to use lists of numbers for representing rhythms. And we will look at how to transform lists of numbers in various ways. The environment PWGL is based on a programming language that is called Lisp, and Lisp stands for list processing. Lisp is an acronym, list processing. And what we are doing today is looking at how to process lists in this video. Okay, what we have here is a starting point. I will at a later stage explain how this box has been created. For now, I'm just telling you that this box is there to turn number sequences, like this number sequence, into rhythms that can be played on a drum kit, on different instruments of a drum kit. So as you see, it says here bass drum. This number sequence saying a quarter, an eighth, a quarter is quarter note, eighth, quarter note. So it's just a normal, straightforward rock rhythm pattern. And if you evaluate this box, turn it into a score, or if you want, for those of you who prefer not to read a score and the rhythmic notation there, but instead read more like a piano roll notation, like presentation, I'm also using the 2D editor here. So if I evaluate this, and I have done this before, then you see it has this quarter note, eighth, quarter note. You can for playback in this video I'm using instrument from Native Instruments, just a drum set based on Contact Player Abbey Road. So if I just play this now, this my keyboard, see, rather straightforward. That's what I'm using just in the background here. So just playing this again. Some straightforward rhythmic sequence, just represented by a number list. So just to get this point across, let's create another number list, and I can a bit better see what I'm typing. 1, 16, 1, 16, 1, 16, 1, 16. That should be for 16th, and by default this is automatically surrounded by parentheses. Sorry, and to put this, pop this into there, keep this popped in here. And now we have just 4 brief sequence of 4 16th notes. Now we start processing that. One straightforward way might be, I want to have these 16th notes of the snare drum repeated 4 times to last for the whole bar. So we'd use Control, repeat, PWGL repeat. I repeat this list. I repeat it 4 times for 4 beats. And then you can see I get lists of lists. Yeah, look at this here again. I get nested lists, 4 sublists. I want to have a flat list, and for that I use Lisp. Oops, it's a list flat, and I flatten my whole list, which transforms my list so that it is not nested. Yeah, look at this again. Now you see, before it was nested, now it's not nested again. So I did the first straightforward list transformation here, taking a list, repeating it. Yeah, so basically appending itself multiple times, but then making sure it's all flat. So I'll take this now and put it to the second import, evaluate this. You see now the light gray is the rhythm of the snare drum, which now goes in 16ths across. Very simple, straightforward rock rhythm pattern. Later on, it's sometimes useful if I repeat some rhythmic pattern multiple times, and I prepared some blocks for that. I'll also look at that later on, how that's implemented. For now, I just pop this in between, and this will do the same what we just heard, but now 4 times. Just repeat and loop basically. And so on and so on. So if at this stage I would have liked my output already, I can either record what I record within Logic, directly the MIDI input, or I can export a MIDI file, import it into Logic, and further process it there, or some other digital audio workstation. And that was shown in another video how to do that. Now, so far, very straightforward. Now let's start to mess around a bit with those two inputs, in particular that one perhaps for now. And as I said, PWGL is based on Lisp, and Lisp stands for Lisp processing. In PWGL there are very many boxes here for processing lists, here more for processing lists. These are all generating lists or transforming them, here for more. So I'll just use some of those to show you a bit what kind of transformations I can do, and that's intended to encourage you to explore those boxes on your own and find out what you want to do for your own project. I'm not aiming here for generating some full-scale drum loop, but mainly what I'm doing is I give you a range of the possibilities. I'm not exploring how we now create the perfect drum loop. I leave that to you. I'll just give you a bit of an insight of the tools we have here, so that you know what kind of playground we have here. Okay, let's start by grabbing this box and just starting with something rather straightforward, and that is the box reverse that gets a list and just turns it the other way around. Yeah, before we had quarter, quarter, eighth, eighth, quarter, and reverse will basically start at the end, quarter, eighth, eighth, quarter, quarter. If I evaluate this, you can see again in this lower line, quarter, eighth, eighth, yeah, and if I have this here, okay, it didn't play the first one, just do that again. And so on. So this takes a list and reverses it. Now I'll throw this box away, but just remember, whenever we are doing other things, all your results, you can always try that, just reverse it. Here's another idea. What we are doing now is taking a list and rotating it. And for that I go to Sets, Combinations, and the box I take is Permit Circ. My box gets in here. I expand this by, remember, pressing plus. And by default, leave this set to 0. Press V. By default, it does nothing. You see, 1, a quarter, eighth, eighth, a quarter. If I set this now to 1, then it starts with that one. A quarter, eighth, eighth, a quarter, quarter. If I do this with start with 3, then 1, it starts with that one. And so there's an eighth at the beginning. And we have then the quarter, so the whole rhythm is somehow offset. Now I'm just playing. Here's the first. Remember, this box repeats that 4 times. I'm setting this to 3 and shift it so that it starts on the second 8th note. Then everything is shifted. Now, it might be interesting to actually change this every now and then and not change it only once and then have that constantly on that same change. So how about remove this all? I'm showing another box under list X append. That's a box which expects multiple lists and appends them without creating sublists. Yeah, so we don't need to flatten it in the end. In the beginning, let's say I give it the original box, then say I'm giving it the shift, which shifted so that it starts on the 8th note. Then copy, paste. Then I shift it only very slightly. So that's the first is the original, the second one is this shift, the third one is this slight shift, and the fourth one, let's keep that like original again. And now we take out the repetition in the end. Oops, we come back to that later. Connect this here. And now you will see we have a variation of different rotations. If you want to have the 16th notes also playing all the time, I will just repeat the 16 times now. Start with the normal. Now it gets shifted. Now it gets shifted, so that's more normal. And at the end it plays the original rhythm again. So you see, with those kind of tools, you can, it's basically you have a programming language for you describing how your sequences are created in a bit more high level way. And yeah, that is a very powerful tool to create longer material that you have various transformations and append them. Here's another way to do something similar, but now with this box we set in advance that this happens 4 times. Let's make it a bit more flexible. I remove this box and move those to the side. And I'm showing you how, so far we created loops here with PWGL repeat. Now we are creating another loop where the input can change across multiple iterations of the loop. For that we go to control again, and here under PWGL map you see repeat is one loop, there's another loop. This box comes actually in 2 boxes. Here comes in the input of my first, hold on, I first connect this to show what it does and then explain it. Here goes in the input. Let's say we want to have the input being the number that changes over time. And my original rhythm sequence goes still up here. This gets now deleted. In this sequence, we now write how the boxes, the nth value, which we said before was 0 and then 3 and then 1 and then 3. We set this now here. Initially no transformation, then transform it so that we start with this offset rhythm starting on the 8th note. then have this more easy transformation, and then have no transformation again. And if I evaluate this, then you see, showing this, removing everything, showing this again. You see, this is the first unprocessed. This is the one which is rotated so that it starts by rotating it 3 times. So it starts on the 8th, starts on that 8th. And then there's the other rotation that starts on the second element, yeah, where we set this here to 1. And then no rotation again. With this box, in the end, we need to flatten the result again. But the power of this, yeah, I'm showing again where you find this under Control PWGL map. Then it creates these 2 boxes. The power is that you can control how the rhythmic transformation, or how the list transformation more generally, yeah, what kind of input that gets and how that changes over time. So if I reevaluate, it gets exactly the result. Oops, sorry, forgot to flatten. List flat. Now it gets exactly the same result as we had before. Unchanged, now shifted. If we start with an 8th note, and so on and so on. But now the fun is we can change only those numbers. Let's say I have the original, now shifted 2, come back to the original, now shifted 3, come back to the original, and play again the original. Just to make this similarly long, make the number here a bit bigger. And yeah, so with only this sequence, we control how this transformation has different iterations of transformations over time. That's the 3 one, and so on and so on. You got the idea. Yeah, so just because this is such a core idea, I'm repeating again, we created a loop with these 2 boxes. And the input for this box specifies the value that if the loop goes through there multiple times, each time it takes the next value from here. Yeah, this actual transformation takes the next value, and we set that, and we are using that here for specifying how far our rotation of the list rotates. So no rotation, then twice rotation, no rotation, 3 times rotation, and so on. And we had to flatten the result because this returns a list of lists. Okay, you see, I'm just in this tutorial show a number of ways to transform this. Now I throw this all away, only those, and show another box how we can transform something. This time I'm going to sets combinations again, but I use this permanent random. Let's say we want to introduce some humanization, some make these rhythms less uniform, less quantized, yeah, dequantize them if you want. This box, hold on, I didn't mean permanent random, I meant actually a different box, Gialia, sorry. Where's that? I actually meant that one, sorry. For different quantizations, unquantized basically, I randomize this, sets a percentage. If I press here, you see the name of the box input is percentage. This sets how much this rhythmic sequence, how much those numbers are randomized. If I evaluate this, then they are not fractions anymore, but they are, yeah, so this was 0.25 originally as a quarter, and it's now a bit, you see, randomized, this again a bit randomized, and so on and so on. If I play this back, you will feel that this rhythm, the 16th notes, and this rhythm, they are not properly aligned anymore. Hold on, I may repeat this a bunch of times, but for now I just set this back to have just a short. You see, that's here, that's not really fitting. And if I evaluate this again, it's just like back too much. If I just do this very slightly, then it is still almost fitting and just adds a bit of a rhythmic interest. That's what happened now. It was a bit laid back. If I evaluate it again, just a bunch of times now, they are all moved a bit forward. And so on and so on. I was before showing, I'm just showing a range here. I was before showing we can randomize the order of them. That was this permit random, what I just showed. That takes those elements and just shuffles around their order. See, that can be something, randomizing something. Some input can be a very straightforward way to generate some variation of an input. There can be too much of variation initially, and you want to perhaps have something less drastic transformation before, but if you evaluate it multiple times, then you can have various versions and then pick what you prefer most. Okay. So far, we hardly changed those inputs. We changed them once when we were quantizing, but how about we are stretching or shrinking our rhythmic values? For that, I use now the arithmetic box, and you may remember from previous tutorials that those arithmetic boxes are smart enough that they can handle lists. So if I put in here 2, then before we had quarter, quarter, eighth, eighths, quarter. If I evaluate this, you see it's now half, half, quarter, quarter, half. Made it double as long. We can also do the opposite, just make them half as long. I adapt the duration here now to have the 16th notes running along. Many digital audio workstations offer something similar, and you might feel, so what? You've done that before. But now the tricky bit is that we can have put in here pretty much any number and have come up with a bit more interesting transformation. So for example, how to make it longer, but make it 1.5 longer, not double it or half it, but make it 1.5 longer. And for that, we change this also to 6. see, our time signature basically changed. But even more crazy might be to turn this into triplets. And I'll adapt. Let's see whether I did that right. Yeah, and it can be even more. Yeah, and we can layer different rhythmic values, different rhythms. Keep this as it is, and copy or paste. And changing those values a bit. Have another quarter and another quarter, say. But now I turn that into triplets. And I put those triplets to the hi-hat just for fun. Just make the hi-hat a bit louder. I can change the velocity values here, make the hi-hat a bit louder by changing all the velocity values for all the hi-hat notes constantly. Just showing this again, what we, if I'm just changing the rhythmic layer here. I'd make this even louder. Oops, that's too much. And now there are a bit different hi-hat rhythms. Yeah, so welcome to Polyrhythm. We can do loads of fun there. Instead of multiplying, what we did here is just multiplying a rhythm. How about we are, instead of multiplying, adding a value? What happens then? I'm going to arithmetic and go to add and take my original rhythm and add 1/16 to every note. And if you evaluate this, you see we have 5/16, 5/16. What does that rhythmic value mean? For those of you who read rhythmic note, oh, hold on, let's evaluate this again. For those of you who read rhythmic notation, you see basically our note, the quarter note, has a 16th note tied to it. Then we have another quarter note, has a 16th note tied. It's a bit hard to read. You get the idea. So that's another way to stretch the rhythm, but to stretch it so that it becomes uneven, that proportionally the longer notes get less longer than the shorter notes. The shorter notes are, for the quarter notes we add only a fifth of its value, for the others we only add a third. Yeah, so the whole rhythmic sequence gets less even. Yeah, we could add other values here if you want to. Okay, come on. For example, have an 8th, then makes them all the notes potentially a bit more even, makes them more. And remember all these transformations what we did so far, yeah, you can have multiple transformations done. All the things what we showed so far can be combined with this. Now I'm going back a step and try to have this both set so that in general they have the same overall length. And for that I'm using the box on G-scaling sum. I specify that the overall sum of this box should still be 1. Yeah, so this is all together 1. If I add something here, let's turn this back to 16. Yeah, then we had those fractions. If I now make sure that all of them, yeah, I added a 16 to every node, which makes the whole sequence a bit longer. If I make sure the overall duration of that is still 4 beats long, yeah, then it dubs them all a bit. And then set this back here to 4. And they are of an even duration again. And so this is a further shift. As I said, and there's one note missing. So this scaling sum makes sure that the overall duration of this is what I specify here. If I want to make this half as long, I could specify this is 2 beats long. And then I set this back to 8 to make sure I have the same. Yeah, now we have a very slow bass drum. There you see, there are various ways to somehow add some hiccup to your rhythm. I showed before that with the loop, what we can do is that we have some transformation and then have multiple iterations of the transformation, and the iterations change over time. That if you do this multiple times, that it has uses different input values. Now I'm showing a different technique which does something similar, where we have some transformation that takes some time, and by it gets from one to something different. I'm removing all this here for that. And that box is called interpolation, what I'm using here. For that, I give it 2 rhythms. Move this a bit out of the way. Let's keep this as an original rhythm and have a second rhythm, data text box. And for the fun of it, let's have some dotted rhythm here. 3 16th and then 1 16th, so that's done, something like that. And then we have quarter and perhaps again, or let's say then I have a long half note. Yeah, just playing that rhythm in the drum, in the bass drum, or without the other. And repeat it. Yeah, so some dotted rhythm. This is my first rhythm, this is my second rhythm. If I evaluate this box, this is my first rhythm, this is my second rhythm, and in between I have some intermediate values. Yeah, it morphs basically one rhythm into the other by changing their values. This does is now for 4, let's say it should do this for 6 values, so 4 intermediate steps. This specifies what kind of curve that does. Let's ignore that for now. but the result should be flattened again. Sorry, just flat. List. Yeah, now it transforms one rhythm slowly into the other, and then if I take out this repetition, it's a bit more easy to see in the graphic. Yeah, this original rhythm, and then by and by it transforms into this dotted rhythm. In order to make that more clear, it might be useful to bring back our snare rhythm there to get alongside it. Sorry, this was 6 times, so it needs to be 24. Not 24? Oh, regardless. I just leave it like that now. The original rhythm, now by and by it morphs. It's over. Yeah, I can repeat this, but let's see what number do I need to enter here to make them even. Now I'm doing a bit of a guesswork. That should not be right. Okay, I just leave it like that, you know. I now let it run in a loop so that we more easily recognize this transformation. Moves more and more towards the dot rhythm. Now we have a dot rhythm, and now it just jumps back because we just repeat this rhythm. What we could do instead is to do this interpolation backwards, go back to the other one. But yeah, you get the idea that we can create rather unconventional, let's say, the unconventional rhythmic transformations with our extensive toolbox we have here. And let me just remind you, I didn't even look at all of those boxes. Yeah, I leave it to you to explore them further. Yeah, there are more. Just to remind you how to explore those boxes, if I don't know what it does, I select a box, press D for getting its documentation, and it brings me a brief summary of what that does. If you rather have some interactive documentation, you can go under Help, PWGL tutorial. If you installed, as described in the installation process, the user tutorials, then under user tutorials, kernel boxes, all these boxes, or most of the boxes, have some documentation here. So for example, if I go back to, if I remember where that was, interpolation under num series, I think. Yeah, there. Then it explains here with the example patch how the interpolation is done, and there's some text explaining it here, but more importantly, we have some patch explaining the details and what the settings are. And also remember that we can combine all the things we had before. Yeah, so this is doing some interpolation, but yeah, we can reverse some elements. We can, yeah, this is just combining freely. So just for argument's sake, why not add what we had before here, the triplets on top. And then playing this rhythmic transformation, and now we have some triplets on top. And within your digital audio workstation, what you could do is, by and by, with fading, bring in one of these layers and then fade out another layer. Perhaps have more layers generated. Yeah, to summarize, what this video showed was we used value sequences, yeah, like this one. And these were lists of numbers, and we transformed these lists in various ways. And in this example, we used those list transformations always for generating some rhythm. We could also do the same for generating some pitch sequences or for generating some, say, velocity sequences. Yeah, velocity values for the MIDI playback. PWGL is based on a programming language, as said before, which is Lisp, and that stands for list processing, because we have so many built-in ways, and you can also define your own, to generate and transform lists. That opens a nice playground for exploration of musical material. I would like to at least briefly explain how the box drum rhythm actually works internally if you want to recreate this. With my students, I will share this patch and that box in class, but yeah, I'm also explaining here how this box actually works. If I double click on it, this is a sub patch. We haven't introduced sub patches so far. It is basically a sub patch. If I double click on this box, it opens another patch. The idea is that patches can become more and more complicated, and to organize our patches, it helps to have certain functionality encapsulated, wrapped up into some sub-patches. You can have sub-patches and sub-patches and so on. I'm not explaining in this video how to create your own sub-patches called abstractions in PWGL. I'll do that a bit later. But here, I just mention this is a sub-patch. Within that box, the main box which does most of the work is this simple layer to score. You get that if you went into the installation video I showed in the beginning and have the library Studio Flat installed. If I am just opening I load the library. There is this library, version 100. And within that library, we have the box Studio Flat score, Studio Flat score, simple layer to score, which is this. Disregard this for now. Actually, I can delete this. This is only, there's some small internal detail if we have not fractions input, but floating points which were created by randomizing, humanizing our input, then we need to somehow clear that up. This rationalize turns fractions into, turns floating point numbers into fractions. And this is a loop which does that for all, this is a loop which does that for all the numbers in one part. And this is now for all three parts. Let me just get rid of this for now and instead show that we go with a rhythm sequence in here. Yeah, that's a bit simpler now than patch. So simple layer expects some time signature, which was always 4/4, tempo always 60, and then the rhythm first of the bass drum. This box, gets the rhythmic sequence. The rhythmic sequence, you see that at the lower end of this window gets in here. And I wanted to have the pitch sequence of the same length, so I take this rhythmic sequence, the length of it, and then repeat one number that often times, and this number is the pitch to play back a certain instrument with a drum kit. If I play this pitch, that is C2, that's the MIDI note for playing the bass drum, and this MIDI note is represented by the MIDI note number 36. That's how this 36 comes out there. 38 is, that's a C, C2, that is D2, which represents our snare. Yeah, if I play in contact, if I play a D, then it plays the snare, that's 42, and the F sharp, that is this MIDI note number 42, then it plays the hi-hat. So for this drum sequence that is repeated that often, yeah, so this drum sequence goes directly into the rhythm input and this repeated pitch. Yeah, just 36, 36, 36. You can see at the bottom end here or there, lots of 30. That's all bass drum. Pitches are all in here. The pitches for the second layer, snare, the rhythm goes in here. And do this again. The rhythm goes in here, and is repeated, and then the pitches go in there. Hi-hat, rhythm goes in here. Pitches are repeated, go in there. And then this part of the patch, this is the most important bits of the patch. This part of the patch you could actually ignore. That is just there to have some distinction between the velocities in the different parts. This box you find in my own library, PWGL cluster rules. And if you have downloaded that library some time ago, you would need to upgrade that because that's a new box in that library. I put it there because I have similar boxes there under cluster rules, under score. There is now set voice velocities because I had similar ones here. So I just added it there. If you import a score into set voice velocities, then for every voice you can set the velocity values, and this is done here again with PWGL repeat. So it's the same length of my bass drum, how many notes that are, and then it is repeating the bass drum velocity, and the bass drum velocity has been set on the outside to 110. Yep, sorry, not that patch, but this one. Yeah, so that's taking this value, bass drum BD, well, bass drum velocity, and then repeats that and does the same for the velocities of the other rhythmic layers. This is the output of the abstraction, and these boxes are all the input for the abstraction, explaining that this box, those inputs, they end up at these boxes. So to briefly summarize, the main box is this: rhythm values get in, pitch values are repeated, get in, and velocities are set. This is another appendix, if you want, for this video, explaining another box I used for repeating some drum loop. This box generated our drum loop. This box repeated it. And I'm just briefly showing how that works. You see, this is not as complex as it drum loop box. This box uses internally boxes from a library, which are developed by Kilian Sprotte in German, KS Quant. And I also explained in the installation video where to find that. It uses score to simple, that's the first box, then score append, and then simple to score. This box returns a score, which can be directly input into a score object, into a score editor. But a score is an object where we can only with difficulty do things directly. Yeah, that is represented graphically with this rather opaque representation. Score to simple turns a score into a relatively simple textual format. If I just show briefly how that looks like by printing it. Now I used this pprint object here, or pprint box here. Pprint stands for pretty print, makes the printing a bit more easy to read. Evaluate that. You can see in my output box, make that a bit bigger. That's the whole score, one part, next part, and so on. And in each part we have the notes, we have the pitch, we have the velocity value. So it's all that information is presented in here. But at the level what I'm doing with this patch, I don't actually need to bother too much about all those representation details. All I'm doing is I take with this simple append this same score 1, 2, 3, 4 times and append 4 identical score copies, and then turn the resulting score, which is longer, again with simple score to score, into a score that way. I repeated the score 4 times.